Okay, so we're going to continue on with trying to understand circumstances where we might want to use a t-test. And the scenario that I'm going to talk about now is that I've got a coal mine. So this is my, my stylistic representation of how a coal mine works. And really, this is why our main power stations are down in Collie. So in Western Australia, the ore bodies are down in Collie. And basically what you do is you build your power stations next to the coal mines. You basically crush the coal and you blow it into these burners and burn it, and away you go. Now, so my setup for talking about this is to say, well, if you're in the coal business, so let's assume that you are in the coal business, there are a couple of things that you need to be aware of. So we're trying to set this up as saying, we have substantial electricity generation in this state that comes from coal-fired power stations. Let's have some realistic context. Regardless of what we think, we're going to have coal-fired power stations for a while. I'm quite confident that there's a limited life for our large power stations that are coal-driven in this state, but we're working through those steps at the moment. So let's say, given you're in the coal business, you need to supply this coal to a power station. Now, one of the things that's going to be in the coal is the ash content. So you're going to have different qualities of coal across your site. You're going to have some really great coal in terms of having a really high calorific content, really great to burn, and you're going to have some less good stuff that is less good to burn. And the thing that I'm talking about here is probably, okay, there's the energy content, but the ash content. So when you're running a power station, the ash content is an important thing. It's a messy thing for you to have to manage in terms of what you do. So you will have a real contract, and the level I've set here is a level that I've spoken to some people at Western Power and said, what is really the ash content of the material delivered to Muja A or Blue Waters Power Station? What are we really talking about? So these are realistically numbers. And so we've said that, look, the deal is if you deliver your coal that has a high ash content, then we will apply a financial penalty. That is, we won't pay you what you think you're going to get for your coal, because me as a power station operator, when I have a high ash content, it's really quite problematic. Now, if I think about that then from the guy selling them the coal, if they give away all their good coal, they're going to be left with all of this. So it's the stuff with the really low ash content. Then they're going to be left with all this high ash content coal that they can't sell. So really the objective is to blend it. So you've got these two things. If you deliver all the high quality coal to the power station, they just pay the fixed price. So you're not getting as much profit from your coal mine as you want. And that's really what you want to do. But if you deliver all your crappy coal to the power station, they're going to hit you with a really severe penalty on the price that they pay. So there's a really strong incentive for you to deliver high quality coal, so that the guys that run the power station have one incentive, you that run the coal mine have one incentive, and let's not even talk about the environment at this point in time. So this is the idea. We're going to sample, we're going to decide what we're going to optimize for profit, how much coal or what the quality of the coal is that we deliver to our coal mine. And the idea is that we want to have our ash content at around about 18%. So I'm not going to measure in percentage terms. I'm going to measure between 0 and 1. So 0.18, that's my sweet spot in terms. So if I can deliver at 0.18, I get my maximum profit. So what I need to do is I need to make sure that I blend my coal resource that I'm mining before I deliver it to the power station. Okay, so how are we going to set up our problem? So what we need to do is, this is our job. We need to, understand how to profit maximize from this coal mine. We've set up a null, so we formalize the problem. So we have a null hypothesis, which is that the mean of the coal we deliver has an ash content of 18% or 0.18, and the alternative is just not equal to 0.18, we're going to have this decision rule threshold, always going to be 0.15, and then we're going to load our data into R to conduct the investigation. First step in any investigation, so this is what we would be doing if this was our job in the coal mine, and it might be something that a well-qualified graduate would do. We would look at the distribution, and you can see this is our measurement. So we've got a lot of measurements of coal where we're above the threshold. So if I'm just looking at that, my mean, so I've taken some samples. I've actually taken 65 samples along the next batch of material that I'm going to deliver to the power station. The mean is nearly 27%. So I'm looking at that and I'm, well, am I going to get away with delivering this coal to the power station? Are they going to be able to say, actually, the coal you've delivered to me is too high in ash content? And looking at that, yeah, I've got a few observations below 18, but most of them above. So for me, I'm really worried about this. So just on the plot, so the plot is really informing me and my thoughts. Is this a normal distribution? Interesting observation. I simulated this data, and so I know it's actually drawn from a normal distribution, but it looks far from normal. So I guess that's the reason that we need some formal tests of these things, as well as looking at the visual plots. So what am I going to do? I'm going to conduct a t-test. So how does my t-test work? I look at the data that I had. So it was my ash data. I applied the t-test function to the variable ash value. So that's the, remember we know data matrix, the rows are the units or the cases, the columns are the variables. So the variable is ash.value. I want to test whether the mean is equal to 18%. And what do I see? I see that I get a really small p-value, get strong evidence that to reject the null. So this is not a good thing for me. So, the test is one thing, but what do we do with the test? So our conclusion. So we make a conclusion, formal conclusion, which we write down. We reject the null. Now, what does that mean in practice? It means that, well, what I need to do is blend the coal. I need to get some of my higher quality, lower ash content coal, blend it with this material so that we can see what we're doing. So this is practical application. So why did I want to do a t-test? Why did I want to learn about R? Only because I had a problem that I needed to solve. So statistical tests are all about solving problems. They're useless in and of themselves. We've got a problem, we wanted to solve it, and we now know not what we need to do. So we'll blend it again, and then we'll set up another test. And when we would pass when the samples pass the test, then we would send it off. And that's an opportune time to stop.